Okay, welcome to the last lesson on compound interest, and this is learning target 11. It's calculating interest rate and payments using technology. So we look at these three equations that come up in the notes. This was n, it has to be a 36. So if you can just make that change. If we look at these three equations, we ask, is it possible to solve each of these equations? For the first one, we could actually calculate this first and see that yes, it is possible, and we did that in the last lesson. This is solving for the regular payment. We noticed that it was a little bit of more work from solving for PV or FV, but yeah, we could do that, no problem. The next one was solving for N, and we've done that actually before, where you can isolate everything and solve for N using guess and check. So it would be a little bit challenging, but if you got down to 1.02 to the N equals a number, you could solve it. The last one is actually impossible. In university, you learn a method called linear approximation to solve for the interest rate, but that's all it is at best is an approximation. And so we actually can't solve that without technology. And so there's two ways to do that. You can use a TVM solver or a spreadsheet, but we're going to focus on the TVM solver today in this lesson. Technology is used to help to solve for unknown interest rate or number of payments in an annuity. Using the graphing calculator or spreadsheet, we can solve quickly for an unknown value. In fact, we're unable to solve the interest rate by hand, so we will need a computer for help. These are some of the terms that we're actually going to use for the TVM solver. In a graphing calculator, we have a spreadsheet that's shared with you in this folder, and so we're actually going to use that spreadsheet, and I'll demonstrate how to use that. So n is actually the number of payments. It is the exponent that we had, so that's how many payments we make. It's not the number of years, just how many payments, and so it can tell you how long, how many payments you've made, or how many periods you've done it for. I% is the interest rate as a percentage. It's not as a decimal, and it's as given in the question. The present value is PV. The regular payment is PMT. The future value is FV. P per Y is the number of payments in a year, and C per Y is the number of compounding periods. Like if it's compounded monthly, it's 12. Often these two are going to be the same thing, unless it says differently. We're going to leave those two as the same thing. And in the Ontario curriculum, grade 11, they're always going to be the same thing. Some important notes: if you're using this in a graphing calculator, PMT or FV have to be negative, and a value must be entered for every variable. In fact, actually, if you have, even in the shared spreadsheet, if you have both of these things and you also have a regular payment, so you don't want to pay off the loan at the end, you can do that if you calculate the PMT as a negative value. So we're going to just identify a couple scenarios, and we're going to use the graphing calculator or the TVM solver to solve it. So this is a scenario where you could have a present value of a loan of $10,000, interest rate at 2% compounded annually for 12 years, and that's what the formula would look like. If we want to solve for PMT, the inputs would look like this. You've got your 12 payments. You've got your 2%. You've got the per year compounded annually is the 1 and 1. Since we're going to pay off the loan at the end, our future value is 0 and our present value is 10,000. So I just want to demonstrate how to do that in the TVM solver. If we go to the TVM solver, it looks something like this, and the red, we actually don't want to write in the red. So if we want to solve for PMT, we're just going to enter in the numbers 12, the 2. Make sure that says 2%. If it just says 2, you're going to have to type in the percentage symbol. The present value is 10,000. The future value is 0, 1, and 1. And as soon as you enter in the numbers, like if I change this to 14, for example, the payment will change right away. So if we have 12 years to do it, it's this. If we had 20 years to do it, obviously the payment would be less. It'd be $611. But leaving it as 12, you have a payment of $945.60. Okay. The next one, we're just going to look at a future value of 300 at the end of each quarter is $14,000. So the future value is 14,000. We know it's future value because it's the exponent with the positive value. This is the exponent with the negative value. That's why it's present value, or formula with the negative exponent. Just in an example, like there's a bunch of different interest rates this could be. It could be, again, 2% per year compounded annually, but I didn't want to do all of them annually. So we can also look at this 8% per year compounded quarterly. And if we divide 8 by 4, we get the 0.02. And we're going to find the number of years that this takes. So again, we go to our spreadsheet. We click on the tab for solve for n. And we plug in our 8%, our payment of 300, present value 0, future value 14,000. Present value 0 because we actually haven't put any money in the account yet. 4 and 4. And what the TVM solver gives you actually is the number of quarters. And so if we take those quarters and just use a calculator, and the spreadsheet is a calculator, and we just take those quarters and divide by 4, we get 8.322 years. And so since 33.29 quarters, it's the same as like 8.3 years. And the last one, so the formula looks like this. We've got the exponent 36 here. This could be again a future value question with 300 as the regular payment each month for 3 years, and so we know it's a monthly for 3 years because of 36. That's an example of how you could get a 36. And we're going to find the annual interest rate, and it will be compounded monthly. So the numbers we plug in are the 36, the 0 for present value, again the future value for 14,000, the payment of 300, the P per Y, C per Y of 12 because it's both compounded monthly. We just have to understand what the question is going to give us. And so if we go to the solve for I, you can see that like if we have a 36 as our n value, we're going to do a payment of 300. We're going to 0 present value, 14,000 is going to be our future value, and we're going to do this monthly, so 12 and 12. We actually get a 17% interest rate. And so the nice thing about not having to divide the interest rate when you put it in is if you ever have to solve for the interest rate, which is the whole point in using technology, is to solve for the interest rate. The nice thing is that it gives it to you just like you want it. And so the answer, just to look at the last point of the slide, is like this question mark here. What it'll solve for, it'll give you the annual interest rate, and because you put in a 12 there, it'll give it to you compounded monthly. And that's exactly what the question will be looking for, the annual interest rate. Okay? And so you don't have to worry about multiplying it by 12 after, like you do when you're solving for the interest rate in just a regular small compound interest question. Okay? And so really the value is to actually solve for the interest rate. And so number 2 is the best question to work on. Number 2 and 8 are the good questions there. Number 1 isn't bad. It's not an annuity question. And I took out 6 and 10. The outline had 2, 8, 6, and 10. You can do 6 and 10. You can try them. They're multi-part questions, and they use a negative value for the payment. So they partially pay off a loan, and they require you to like plug in a present value, put in a payment, and solve for a future value, and then use that as the new present value. So you can try those questions if you'd like, but number 2 and 8 are the most important ones. Number 1 it's just practice using the TVM solver, and so you get the TVM solver by going into the folder, our shared folder. It's copy of good TVM solver. If you go to the copy of the TVM solver, you can go to File, make a copy first, and then you can actually use it. I just encourage you, don't type in any of the red cells on each of the pages. And if you do, just go back. You can do undo, or you can go back to where you got the original and just make another copy. Okay.